Okay, welcome to another Orbiter 2010 video. And in this video, I'm back with the Dragon, the SpaceX Dragon and the Falcon 9 launcher. I thought what I would try this time would be to take the Dragon out to the moon. And what I'm thinking I'll do in this mission is take the Dragon out to the moon on a free return trajectory. So I won't actually land on the moon. I'll just take it out to the moon, free return trajectory back to the Earth, and then I'll go ahead and do a reentry back at Earth, high speed reentry back at Earth, since I'll be coming back from the moon, and then splash down. I don't know how much targeting I'll be able to do in terms of, being able to, like, say, land the Dragon off the coast of Florida. I don't think I'll be able to do that. Probably just have to splash down wherever I splash down, but that's the goal. So I've picked a date, July 31st, 2006, and the reason I picked this date was because this was a time during the lunar precession where the moon ends up in a really good alignment with Cape Canaveral. You can see we're only 0.17 off with our relative inclination, and it's continuing to get lower. It'll actually get all the way down to like 0.03. I don't actually know what the ideal time to launch is. I don't think you want to wait necessarily till it gets all the way to 0.03, just due to the fact that it will be moving fairly quickly at that point. So maybe around 0.05 I'll launch. So that's the idea. Let me go ahead and jump in and get going. Set the time back to real time. Press G to remove the service tower, so we can see the service tower pulling away. There it goes. F1 to get back inside. And you can see our relative inclination coming down quite quickly. Again, just due to the fact that we're in such good alignment with the moon on this particular date. So actually, I think I might even go now, because we want to launch when we have time to reach half orbital velocity, and that's coming down pretty fast. So I think I want to go now. I probably should have even gone sooner. Okay, we're launching straight up. And we've already got a heading of 90 degrees, so that's good. Press a little bit of 8 to pitch over just a little bit. And by the way, if you don't like to watch the actual launch and ride to orbit, because that might get a little boring after a while, just go ahead and skip ahead to the point where I've already achieved orbit. But I like to record my videos from start to finish without any pausing or stopping or editing, just mainly because I guess I'm too lazy to edit. So the usual stuff here, just trying to get up to orbital velocity, keeping an eye on the relative inclination, and let me bring up orbit MFD. Okay, I've already got it set for ship, already got the equatorial frame, and I got the distance how I want. I suppose I can switch to green now that I'm out of the lower atmosphere, and I can see the HUD better with the green color now. Go ahead and pitch over a little bit more. Maybe I should have went ahead and waited for the lowest relative inclination after all. Guess I can yaw a little bit, maybe improve it. Oh, wow, there we go. That's going fast. Oops. That is sensitive. But you can see by launching on this particular day, we got a really, really low relative inclination with the moon, so it'll save us a bunch of fuel. And this date works. I checked it out. July 31st, August 1st, and I believe August 2nd also. So you got a 3-day window in there where you can get this really low relative inclination. Okay, so I'll be even pitching way over now that I'm up above 70 kilometers. Keeping an eye on the relative inclination. I want to make sure it stays as low as possible. Take a look at the external view. Our other two modules have already separated. Yaw just a little bit there. Looks like I need to go the other direction. There we go. Now yaw back the other way. There we go. I suppose I'm going to go for an initial apoapsis of around 200 kilometers, give or take. We're in pretty good shape. Things are coming along nominal. I imagine we'll be coming up on first stage separation here in a moment. Take a look again at the external view. And one thing I know I can do is press F3, get into the Dragon, and I can press Shift J to jettison those, jettison that fairing now. And actually I can also press Shift B to blow off the solar panels. Just one less thing to deal with later. And I'm pretty sure that that's part of the normal launch routine for the Dragon, is they actually do that before getting up to altitude. So let me begin pitching down, and let me bring back up. The only thing I don't like about switching between vessels like that is that you lose your MFDs. They don't remember what you had selected. We're coming up on orbital velocity here in about 2,000 meters per second. Okay, that's the end of the first stage, and it'll separate automatically. And we gotta wait a little bit to get some separation, because I have actually managed to destroy the second stage before by lighting up the engine too soon, and I assume what happened was the tail blast got caught in the first stage and caused a failure on this stage. So just get a little bit of separation there. Now press Control Plus. Okay, we didn't explode, that's good. Bring up the engine slowly, and there we go. Okay, so I want to be about level with the horizon, pretty close to our target apoapsis of 200 kilometers, so I'd like to just keep things right here until we get a circular orbit or close to it. And we will go for as circular orbit as we can get, because I don't have any more, I don't have to separate any other thing. Pitch down. Pitch down. lot of times when I go for my initial orbit, I want the opposite side of my orbit to be no higher than about ground level. That way, if I need to separate any modules, I can separate them and let them go around and burn up in the atmosphere. But this time I'm taking everything with me, so I want to get a nice circular orbit right here at launch if I can. Okay. Okay, our PEA is coming up now quickly. Go ahead and reduce the engines a little bit, just so I don't run the risk of overshooting here. See, normally this is where I would kill the main engines. Right there we have a nice circular orbit, not quite 200 kilometers, but pretty close to it. I have a lot of dry, scratchy throat issues, so that's why I'm always drinking water. Go ahead and press P to extend the solar array. Actually, got to get into the Dragon first. Now press P to extend the solar panels. And now I need to get back into the Falcon Heavy. And I gotta target the moon again. There we go. Now, I could actually go to the moon without even worrying about an alignment, because I'm only 0.04 off from the moon, which is definitely good enough. But if I do have the opportunity to reach the ascending node before needing to go out to the moon, then I'll go ahead and do a little bit of a correction there. So let's bring up TransX. We've got some work to do here. I've kind of already gone through and explained a lot about TransX in a lot of my previous videos, and I've already done an Earth to Moon free return video, so I'm not going to necessarily explain a lot of detail here, just for the sake of time. I'm just going to kind of go through and do what I need to do. Select the moon. Oops. Turn maneuver mode on. Go through the variables. Usual amount of prograde. And the date. Let me go around one orbit. Forward on this side, view the encounter so I can see what's going on. This little circle here is the moon. This is my projected orbit out to the moon, so I need to keep working on it a little bit. And we're going to go around to the other side this way because we need a retrograde orbit if we're going to do a free return. So that looks really good right there. Now on this side, we'll go to View Setup, Escape, go forward, and when we go forward on that side, it turns Stage 2 into a slingshot. So now over here, we want to go to Sling Direct, outward angle has to be negative. And we want to get down somewhere in this range. That's just for starters. Now we'll back this side up to the slingshot. And now I need to do a couple things. That's pretty far out. Let me get a little closer than that. Let's try 144. That's a starting point at least. Okay, so now I want to get these lined up. Start by working with a little bit of prograde. Okay, go to a much finer adjustment. Okay, that's got us our PE ratio at about 1. Can work with the relative inclination a little bit. Okay, it's about as low as that's going to get. I'm going to go back to the prograde and work on the PE ratio again. And back to the change plane. I think I am going to be better off if I go to the ascending node and work with the relative inclination at that point, because this, I don't think it'll require nearly as much plane change if I do that, because this is showing a plane change of 131 delta V. That's really high. I know I won't need anything even close to that if I do the plane change here, so I'm going to do that. Go ahead and warp time ahead to get to this point. Okay, I'm going to go ahead and go to the anti-normal position because we're coming up on the ascending node, and the AN equals AN. That's ascending node equals anti-normal. That's how I always think about it. And when this gets down to about 1, we'll apply just a whisper of thrust, and that'll bring our relative inclination down to 0. And I missed it.
Translation.
That's okay.
Rotation.
And there we have it. Relative inclination 0.00, and the amount of estimated thrust that's assumed to get to 0.00 is also very close to 0. So now let's go back to TransX and work with this some more. And I'm going to actually reset the maneuver and start over. So maneuver mode off, maneuver mode on, and we'll just start over. Back to prograde. Okay, now over to the date. Make sure I reset the date and then bump it forward. Remember, we always have to go forward with the date because we can't go backwards in time in orbiter. Sometimes I wish I could. It's like, oh no, I didn't mean to do that. Let me go back. Okay. Now I definitely need some more prograde because I'm not even out to the moon yet. So let's... And over here on this point, let me actually turn that off for now also, so I can have this view up. So I want view encounter, and there I've got the retrograde inclination that I want, and we've got a decent minimum altitude. It doesn't hardly matter what you have the minimum altitude at this point, since we're setting up another stage anyway. So now VW, escape, forward, VW to sling direct, outward angle, down to about -145, about right there, back up to this view, and there, that's much closer. Okay, so now we'll work with this PE ratio. I need it to be 1, so let me go with start with ultra. Okay, that's going up, so we'll just keep adding in. Okay, that's pretty good. Let's go down to a hyper. And we've got a P ratio about 1. And the relative inclination is 0.00 and some decimal points. I don't worry about those last few decimal points. So this is good. Let's see what our our focus PED back at Earth is showing. It's 10,000 kilometers above the Earth's center. I need to get that lower. So now let me work with and check something over here real quick. Okay. Okay, that's going the wrong way, so let's go this way. That brings my focus PED down. And there's no good target in my opinion, just something around 6,000 kilometers. Just due to the inaccuracies of the math models, it won't be right no matter what way you go with it, so... But something around 6,000 kilometers I think is good. And again, just as a reminder, the focus PED here, this is what we're saying we want our altitude to be when we get back to Earth. And it's going to require refinement, so I'm just going to set it at this point. And now we'll go check a couple things here. Okay, now I need to refine the outward angle. And what I want to do here is I want to have this dashed yellow line line up with the green, with that green circle. And that'll help me over here if I look at the PE ratio. Okay, that's going the wrong way. Okay, there we have it. Okay, PE ratio is 1. Relative inclination is very low. And our approach out to the moon, we're going to be pretty far above the surface. That's something close to 9,000 kilometers, so we'll get a nice high view of the moon as we go around. Alright, now let's go ahead and get ready to burn this maneuver. Go to prograde, back up, go to VW, and we're going to do this maneuver in 3,000 seconds. Okay. So let's go ahead and warp time ahead to get to the time that we need to begin the burn. Come out of time warp for a minute. Get back to prograde. Okay, warp time ahead. Okay. Okay, go to prograde. Coming up on the burn here in just 3 minutes. Take a look at the external camera to see what we have going on. So we've got our Dragon capsule, we've got the trunk, and we have this other stage, which gives us the power that we need to get out to the moon. That's why I took the Falcon Heavy instead of just the regular Falcon, because it just gives you enough fuel to get up into orbit and be able to have this stage left with you, because without this stage we wouldn't have enough power, enough engine thrust to get to the moon. So go ahead and warp time ahead now. Oops, getting very close.
Translation. Rotation.
Go rotation. Turn prograde off. And right there. So coming up on the burn in 10 seconds. You can see down here. 5 seconds. 3, 2, 1, and burning. Take a look at the external. And this is a pretty cool mission to do too, because it's still realistic. Whereas a lot of the things that I like to do with the the XR2 or even the standard Delta glider, it's not very realistic. But this is a vessel that's still grounded in reality. Go ahead and work with the rotation a little bit just to keep that X nice and centered. What I do is I use Control 1 or Control 3, and then I like press Control 1 and then immediately press 5 to kill rotation. So like right now, Control 1, 5, Control 3, 5, Control 1, 5, and then that gives me just a little bit of burst, and then it kills the rotation immediately. Because even the Control 1, Control 3 is still sensitive enough that it'll send that green X off center. So here, Control 3, 5, Control 1, 5, Control 3, 5. That's pretty good right there. Go ahead and use a little bit of time acceleration to speed this up. Getting close to the end of the burn. Go ahead and back off the main engines a little bit. Get our X centered. Coming up on the end of the burn. And
Translation.
I always manage to overshoot. Apparently we have no translation thrusters in this module.
Rotation.
So I'm going to have to rotate around. Backwards. Waste of fuel. Okay.
Translation. Rotation.
Rotate back around to prograde. And I'll see if there's any work that I need to do. Otherwise. So I'm looking here. Excuse me. I can see that my green line, which is my actual orbit, is lined up very well with the dashed yellow line. But I can also press VW to bring up this view and take a look at the PE ratio. And here the PE ratio says 1.005, so that's really close to 1. So I don't need to work with the semi-major difference. If I needed to work with the semi-major difference, basically what I would have to do, and I do this all the time in the XR2, is I would go to the prograde position just by hitting the prograde button, and then once it gets settled, I turn the prograde autopilot off, and then I use lateral translation 1 and 3 in order to get the PE ratio back down to 1, but for some strange reason, this vessel has no translation thruster, so I couldn't do it even if I wanted to, and fortunately I don't have to because the PE ratio is right in there. So go to maneuver, turn maneuver mode off. Actually, I forgot to turn maneuver mode off, so now once you turn maneuver mode off, then it does show you what your actual orbit is. So I am off a little bit. I will have to adjust the PE ratio. Okay. Let me see if I can do it this way. Press F3 to get into the Dragon. Now if I do that, I'll lose this information. So I'm going to have to do this. Rotate minus 90 over to 270. Right there. And what I want to do is just do a very small burn until the PE ratio is basically 1.0. Okay. And I'll show you that does a couple things here. Okay, there we are right at 1. And also, if I take a look here, now you can see this line. These lines are matched up exactly. So that means that my actual orbit out to the moon is right on track with the plan. And as my plan was good, then my actual flight will be good. Take a look at the external, see where we're at. Passing right back over top of Florida. Okay, so now let's go ahead and warp out to the moon and then come back, and with any luck we'll splash down somewhere. There is one thing I may have to do though. The Dragon crashes a lot when you come up on reentry if you don't delete these this certain section out of this scenario file, so I may have to do that. We'll see. I'll worry about it when I get back. Okay, warping time ahead. Kill rotation. Take a look at the external view as we leave the Earth. And it's one of the strange things about working with the Dragon. Like you saw that glitch there where the first stage, or whatever you call it, the second stage, blew up or whatever. I don't know, this SpaceX module or SpaceX download add-on seems to have a few glitches. First time I saw that I thought the whole thing exploded, but anyway, we're in the Dragon now. Keep an eye on the battery charge, make sure the panels are tracking the sun, and I'll continue on out to the moon. Go ahead and go to 10,000. And go down to real time for a minute, give the panels a chance to retrack the sun again. There we go. Now back out to 1,000. 10,000. Back to real time, let the panels reset. There they go. Let me go around to this view so we can see where we're going. 10,000. Back to real time, let the panels reset. If they need to, sometimes they don't need to. To 1,000. 10,000. Back to real time, let the panels reset. 10,000. Let the panels set.
Translation. Rotation.
Okay, rotation. Okay, back to 1,000. 10,000. And as I'm coming around the moon, I'll just go to 1,000. There is something I want to do when I get to the far side of the moon. Basically, when you get to Earth's apoapsis, which in this case would be basically lunar periapsis, I want to see if I need to do any kind of mid-course correction to, which I'm sure I will, so that I will hopefully touch down at Earth at, I'll come back to Earth and have a low altitude. And since TransX is just way too inaccurate for this, I'm going to use interplanetary MFD just for this one purpose. I'm going to use map, and I'm going to reference Earth, and get into the prograde position here. Quickly bring up orbit MFD to make sure I'm at or past lunar periapsis. I'm not there yet, so I need to go forward a little more. See our external view here. Okay, now we're past lunar periapsis. So we can go back to real time. Go to the prograde position. And what I want to do here, wow, my plan for getting back to Earth was actually quite good. You can see according to interplanetary MFD, my periapsis back at Earth is negative 394. That's a little too low, but that's really close. Usually, when I do this type of free return, I end up with the periapsis back at Earth at several thousand kilometers, which is obviously way too high. But what I can do here is, with just a little bit of translation, I can bring this to where I want it, which is going to be, I believe, like 40 kilometers would be best. And that's just a little bit of a guesswork. And the reason I'm doing it out here at lunar periapsis is because this is just the best time to do this burn in terms of fuel usage. So I'm just going to use a little bit of translation, as much as is necessary. To bring that to about 40 kilometers. I think that's probably about right. So that'll take me all the way back to Earth and bring me into the atmosphere. And interplanetary MFD, I've found, is really accurate for this purpose. There we go. This will probably change a little bit, but it will be very close. And if I were to try to do this with this particular maneuver with TransX, I would be off by a landslide. So, alright, let's go ahead and take a look at the external view now. See where we're at. We're on the far side of the moon, so let's now head back home. Go to real time for a moment, get the panels reset, and we'll go to 10,000 here in a moment. back to real time. Panels. 1,000, 10,000. Back to real time. Panels. Now we'll keep an eye on the Earth. 10,000. Real time. Panels reset. 10,000. Oops, there goes the battery, so definitely need to get the panels reset. Now as I get close to the Earth, I'm going to do a quick save, because what I've found, again with the SpaceX Dragon add-on, it seems to crash on. I mean, it'll cause a crash to desktop, like Orbiter, you know, the executable. It causes a crash. Sometimes it doesn't seem to always happen. So what I'll do is I get in close to the Earth, I'll quick save and then continue on. And if I experience a crash, then I'll reload the quick save and try again. So we're at 1,000. We'll go to 10,000. There's the battery depleting, so go back to real time, let the panels reset. And let me check. Yeah, interplanetary MFD, see, it still shows that our periapsis is 39.78, so it's a very, very accurate MFD for that purpose. Otherwise, I generally don't use it. Not that I don't have anything against it, I'm just more of a TransX guy. Okay, getting in very close. There goes the battery, so we'll go back to real time. Panels are resetting now. Let's go to AR so we can auto-reference the Earth. And when I get in here a little closer, I'll quick save. Okay, let's get down to 5,000 seconds from periapsis and then I'll quick save. Okay, Control S. Now we should be saved. Go to prograde here so we can see where we're going. Now I think at this point we can probably ditch our trunk. Oh my god. And that's why I quick saved. I don't know what it is with Orbiter or with SpaceX. That was lucky that I quick saved when I did. Okay. So let me close that. And let me do this. Come in here to the quick save. And what I found seems to be the problem is this one right here, this section, F9. Actually, it's not that one. It's actually a few of these, so I'm just going to delete them all because you don't need them at this point anyway. Actually, it's this section. It's this debris. So I'm going to delete this section. I believe this is the only one that causes problems. But I'm actually going to delete these just so I just get rid of them. So SpaceX junk. These are just all the extra parts of the vessel that, you know, the panels and the fairing. So let me get rid of those. More junk here. Delete those. Junk. Trash. Trash. Let's see, how many more are there? Okay, this one and this one. Delete those. Alright, I think that's all of them. So now I'll save this. and restart orbiter. It's that one. So let's launch orbiter, and hopefully we can finish this now. Okay. Okay, back to the prograde position. Pick up where we left off. Now let me bring up map MFD again. I don't really know where I'm going to end up at on Earth, but there is actually an MFD I could use to help me determine where I would splash down at, but if I were going to use that, I would have needed to have started it a long time ago, and I didn't think about it. So we'll just splash down wherever we happen to splash down. I'm just debating on when I need to separate the trunk. I think I can get in quite a bit closer before I do that, so let's move in a little bit. Okay, we'll go with that. That's a few minutes away from periapsis, and we're at an altitude of 1,500 kilometers. That sounds like a good time to press shift in. That gets rid of the trunk. And yes, we are in the Dragon. Now what I'll do
Rotation. Translation.
is just translate a little bit so I get away from that. Like that. I don't want to do too much translation because it'll have an impact on my periapsis. But I just want to make sure that when I'm coming down through the atmosphere, this thing is drifting away from me. Okay. In fact, let's double check with interplanetary MFD. Okay, yeah, that didn't have much impact on the periapsis at all. So here we are. We're coming back to Earth on a very high speed approach. So let's go retrograde to prepare ourselves for a very hot ride. Okay. Go ahead and warp time ahead now. Get down quite a ways yet. Can we see the trunk still? Yeah, there it is out there. 11,000 meters a second. Okay, here we are coming up on entry interface. Go retrograde, just to make sure I'm in the right position. And now we'll turn retrograde off as soon as it settles. And go ahead and have map MFD open. I think we're actually going to touch down on land. That's okay. This vessel has land capabilities. Grab the popcorn and enjoy the ride. Nothing we can do. Sit back and watch. Guess I could bring some MFDs up though. Fingers crossed. I think we're in pretty good shape. If we'd done just a little bit more planning, could have probably touched down somewhere near Florida. Maybe out in the Gulf or something. I wish I had brought up the free stream temperature reading. That would have been interesting to keep an eye on. I didn't think of it. Okay, let's close that out, close that out. So we're all the way down to 3,000 meters a second. So here very shortly we'll start falling straight down. And looks like we will be over water. Yeah, we'll definitely be over water when we splash down, so. Okay, I can go ahead and warp time ahead at this point. There we go. There's the drogue. This is usually where it crashes if I don't edit that file and delete that one particular entry, the one that says debris 0. If I don't delete that, then whenever the main chute comes out, I instantly get a crash to desktop. But in this case, it crashed before I got to that point, so. Go ahead and warp time ahead.
2,500, 1,000, 500, 400, 300, 200, 150, 40.
Watch the last few meters in real time. And there's our splashdown. Okay, well, I enjoyed that. That was first time I've actually tried that. I've done a free return before with the Dragon, but when I did it, the Dragon crashed. I crashed the desktop, so I didn't bother to pick it back up and start over because I didn't save it. So this time I saved it and was able to complete it. That was fun. What I might try in another video will be to do the same flight, but when I'm coming back from the moon, I'll use the lunar transfer in FD, and that will allow me, I think, to be able to pick a target so that instead of just coming back and landing wherever, I'll try to specifically target, maybe over here toward Cape Canaveral. So, anyway, that's the end of this video. Hope you enjoyed it. As always, please leave some comment down below, and I'll see you in the next video.